If you need globally distributed, highly responsive database in a cloud, this video might be just right for you. This is Adam, and today I'm gonna give you introduction into Azure Cosmos DB, so stay tuned. Azure Cosmos DB is great. It's a fully managed, globally distributed, multi-master replication database. What this really means, it's designed for high-scale, global replication, low-latency database. But recently it also got some analytic workload capabilities using Jupyter Notebooks and Apache Spark. So how does it store data? Simply said, it's just a document database. A document is a JSON format, so it's an open standard for transferring data. And an example of that kind of data you have on the right hand side. It's a key value pair, where for instance for key you have a first name and for value you have a John, like a name. And also you can not only put simple values, but you can do Boolean values, integer, decimal points, but you can also nest objects inside. So for instance for address you can have street address, city. For phone numbers you can have RIs if you need to. Whatever suits your needs. So it's most commonly used document format right now at this point for programming all the APIs. So let's go into overview of the Cosmos DB itself. What are the key features that you would make you want to use this database? The first one is global distribution. So this database is distributed across all the major regions in Azure across the globe. And it's done transparently, so you don't have to worry about this replication. You just press few buttons and it's done automatically. Which brings me to another point. The regional presence is very great. It's for 54 regions, or more if you count Azure Government and Azure China. Additionally, it has high availability for both reads and writes. It's actually very, very good. Next, you have elastic scale. Elastic scale basically means that you can scale from thousands up to even hundreds of millions requests per second. Of course, this is gonna cost you a penny, but it allows for that flexibility and that scale. You have that guarantee of the low latency. So for the 99% of your requests, the data will be returned under 10 milliseconds. This is of course based on what are you querying for, but the latency is very low. I even experienced that when developing my own applications, and it was really fast. Next, you have consistency options. How would you describe this the easiest way? When replicating data across those multiple regions, the data needs to get there at some point in time. And you can actually decide what is the way that this data will get there. You can either go for some sort of strong consistency, which means your data will be arriving at all regions at the same time, at the cost of the performance and response. Or you can do some more eventual type of consistency. So it's gonna get there eventually, but you will get the highest performance and response time. And there's no schema or index management. What this means is that this database was never designed to have schema in mind. So you don't have your normal define the table, define the columns, the type of the columns. There's no schema. You just operate on the documents, and each document can have different properties. There's only very few properties that always needs to be there. Besides this, you are not strictly defining any kind of schema. And additionally, there are no indexes. Microsoft created Cosmos that it automatically indexes all the data. You can override this with something called indexing policies, but out of the box, you don't even have to worry about the indexing of your data. And one of the most important features of Cosmos DB are multiple APIs. When creating Cosmos DB, you are deciding what kind of API do you want to use when working with your data. The default one, the core API, is the SQL one. It's way of working with those documents using very similar to your normal SQL. So you can query your data just like you would do with any normal database. Additionally, you have APIs for Cassandra, MongoDB, Gremlin if you're working with graphs, but also if you're migrating from table storage to something more performant, you can also use Azure Table Storage API, which allows you to use SDK for table storage. Cosmos DB structure is fairly simple. What we're going to be creating in a second is database account. It's a top-level resource in Azure, but underneath it, you can have one or more databases. This is an equivalent of your SQL database. Within that database, you have something called container. You can think of container like tables, and each table have rows of data called items. So items are the most important way of storing data. What we've seen previously, that document there, that was just one item. Additionally, you can have stored procedure, merge procedure, user-defined functions, and many more. Two things that I want to highlight here are, first of all, containers contain something different depending on the API. So if you're choosing Gremlin, that's going to be graph. If you're choosing SQL, that's going to be collection. If you're choosing table, that's going to be table storage. And again, depending on what API did you choose, the items collection will be either rows or documents or nodes or edges. So the main choice of the API is very critical for designing your Cosmos DB. Critical thing to understand for Cosmos DB are request units. It's basically how you design performance, because Cosmos DB, contrary to other services, you don't pick how many cores, how much RAM do you get. You only pick one measure, that is your throughput measure, and that's called request units. Thing to understand about request units, that depending on what you're doing with your database, you pay more or less request units. So if you're reading a singular documents, that one request unit. But if you're inserting data, upserting, deleting data, that's more request units, depending on how big the change is. And if you're querying data, that's much more. As you can imagine, when querying data, doing some aggregates, you are going through multiple documents in your database, therefore you need to pay more request units. Another important things are partitions. Normally I wouldn't talk about partitions because in databases there are more advanced topics, but here they're one of the most critical things when designing database in Cosmos DB, because you cannot change them after you created your database. You would have to recreate your containers in the database and just re-upload the data. So there are two things that you need to remember here. First of all, container, there are two types of containers, logical and physical. Logical are very similar to how you design it in your database. So you pick what kind of partition is this. Maybe we're gonna split it by city or maybe by an airport. And then they will land eventually in physical partitions. But the physical partitions you no longer decide. It's Cosmos DB engine that decides if they will land in the same physical partition on a separate. Why is that important? Because performance of your query bases on how well did you design your partitions. And lastly, the SQL API that I already mentioned, I just want to show you how does it look like. It looks, as you see, very similarly to your normal SQL. So you do your normal selects, you can do joins, order bys, or more complex solutions that I'm gonna show you in a second as a demo. And lastly, the last key feature that I wanted to highlight for Cosmos DB is the change feed. Change feed is an amazing feature of Cosmos DB, which allows you to seamlessly connect to your computing resources in Azure, like Azure Functions, or maybe some streaming like Azure Stream Analytics, HD Insight, maybe Databricks, etc., which basically allows you to react to changes in Cosmos DB as they go in, do some computations and go back, and save maybe some results, do some analytics, whatever is your need. But this is amazing how easy it is because just few presses of the button. So right now we're gonna go into Azure portal and prepare our demo. So in the portal we're gonna create a Cosmos DB resource right now. So let's go hit create resource, type Cosmos DB. Let's hit Azure Cosmos DB, hit create. We need to provide a resource group, so I'm gonna choose the one that I created previously. We need to provide the account name. Account name is very important here because that's gonna be your public URL to your database. So let's type am Cosmos demo. That's available. Let's choose the API. I'm gonna choose the core SQL because I want to show you the queries. Right now, there's already option seen in the portal for Jupyter Notebooks and Apache Spark. This is this advanced analytics that I was talking about. And next we pick the region. This is the main region that your Cosmos DB will be residing in. So we pick North Europe. And I'm gonna choose geo redundancy as disabled and multi-region writes as disabled because it incurs additional costs and I don't need that for the demo. So I'm gonna hit review and create. Everything seems to be fine. And I'm gonna hit create. Because this process takes about 4 to 5 minutes, I'm gonna skip ahead right now. So the provisioning finished, we can go to our resource. The basic tab that will be presented in is overview. The overview tab and overview blade actually gives you most basic information about the Cosmos DB that you created. So the most important one, the status, so the database is currently online. The database has currently only one read region, that's North Europe, and one write region, that's also North Europe. And this is the URI to your database. So if you're gonna be connecting from any kind of API or a code to this database, you use this URI. You additionally have a very cool tab here called usage. You can actually track your hourly usage of the Cosmos DB, so you can easily see what is the cost and easily estimate what will be the monthly cost of your database. But the most important blade is Data Explorer. This is the blade where you're working with your database entities. You work with your database schema. Well, it doesn't have a schema, but the structure, but also data. So the first thing that you need to do here when creating database, you need to create a container. But when you try to create a container, it will already say that you don't have any database. So you need to first create a database. I'm gonna call it my to-do. So this is gonna be my database where I'm gonna be storing to-do application information. Second of all, you need to provision a throughput. As we were saying, throughput is your performance, an hourly performance managed in a request units per second metric. So the lowest that you can use here is 400. 400 already is $23 a month. You can actually see that on the top here. So that's 23 something that averages to 24. That's the smallest you can get. And it will very quickly grow if you're gonna start creating multiple region databases, because you're gonna pay that throughput for every region database and also for the replication. Next, we need to pick the container. This is equivalent of our table, so I'm gonna call it to-do list. And I need to pick a partition key. A partition key, as we said, this is the way for Cosmos DB to know how to split logically your data, but also how to split it physically for the performance. I think on my to-do list, the common key that I will have on every single entity that I will put into database will be category. And I think that's it. I don't need to specify anything else. If you have some unique keys that you want to validate, so this is the, let's say, the smallest type of schema management that you can do, you can add that unique key here, but I don't want to do that right now. I'm gonna hit OK. And what will be done right now, a database will be created in Cosmos. This is my database that was created, and a collection, a single collection, to-do items. So as you see, we got a couple of things here. First of all, we got the items. This is the list of the items that are currently within this collection. You also have settings, so you can do some tuning of your data and how the collection is being maintained here. You have stored procedure, user-defined functions, and triggers. We're not focusing on those three right now because this is a bit more advanced topics. So let's go back to items. In items tab, you will quickly notice that you have a select star from C, which basically means give me all the items from this collection. We don't have anything right now, so maybe for the demo, let's create two entities. You hit on the new item button and you need to specify. The only property that is required is ID, but in our case, since we created also a partition on the category, the category key will be also required. I already prepared some sample data, so let me paste that in. So first one is ID1, it's a personal to-do item, and I need to pick up groceries. So I'm gonna hit save. I got one item. Notice that Cosmos DB additionally adds some properties of its own, like a tag that is used to track the changes on this item, the timestamp that is encoded, and a couple of things that are here. And let's create a second item. So let's hit new item again and copy paste the second item. This is another to-do item. And right now we have our items. And this is as simple as it gets. If you want managing data from the portal, this is how you do it. If you're managing it from the code, we're gonna see that example in just a second. So how do you query this data? Since we picked the SQL core API, we can now query the data. To query the data, you go here, click on the new SQL query, and you just type in query. If you hit this default one, you're gonna return all the items. So as you see, this is the collection of 2 items. But what is great in the portal, that you additionally get query stats. Query stats is a table telling you how much request units did you use for this particular query. So in case listing all 2 entities that we have in our collection cost us 2.31 request units. So a bit more than 2, because 2 was just reading 2 items, and those 0.3 request units was just to crawl all the data, go through, combine this together and return it. So you can easily check how much does your query cost. So if we maybe order this data by some property, like a timestamp, since you remember _ts is a timestamp, and execute this query, notice that the query cost us a bit more, 2.94, because additional job has to be done by Cosmos DB in order to return this data. And go back to result, and as you see, we ordered descending by the timestamp. So what we need to do right now is go and do another demo with dotnet. I just want to quickly show you how easy it is in dotnet to also connect to database like Cosmos DB. So I'm going to my empty Visual Studio Code where I'm gonna be developing my application. I'm gonna zoom it a little bit in. So let's start developing now. Since we have it zoom in, let's go into and create new console application. .NET new console. This is gonna create an empty console application, which I'm gonna restore packages to. And it's simple hello world application. The next thing that we need to do, we need to add a Cosmos DB package. To do so, type .NET add package Microsoft Azure Cosmos. And once it's restored, we can already start using it. What is great here is that this package is right now in version 3.11, which brought a lot of new features that are available for Cosmos and more streamlined coding syntax. So what I'm gonna do right now is I'm gonna copy the code that I prepared previously. So I'm gonna paste it here. I'm gonna fix some usings, control and a dot, using tasks and using Microsoft Azure Cosmos. And the only thing that is left is copy this, paste here, type wait. Of course, this is not the best way to do asynchronous programming, but it's good enough for our demo. So let's see what this code will do. First of all, it will initialize the Cosmos DB client using the URL and a Cosmos key. The next, it will create database if no exists. I'm gonna maybe create new just to show you this works. I'm gonna call it DemoDB. Then it will create a container called myContainerName if such doesn't exist, with a partition key called partition key path and a 400 request unit performance. And then it will create some dynamic object with an ID, partition key path, and some additional details. And lastly, it will call container and create that item. So what we need to provide is the Cosmos URL. First of all, let's go back to the overview. Let's copy the URI of the database here. And we need to copy the key. So we go to the keys blade and copy primary key. I'm gonna stop here for a second just to tell you, make sure that your Cosmos DB key is safe. because that key allows you to also create additional databases and change throughput, so you can pay a lot of money if this goes into unauthorized hands. So just make sure that it's very safely stored. So I'm gonna hit F5 now. This is the .NET Core application. I'm gonna hit F5 again, just to debug, let it run. And it finished. So if it did finish correctly, we can go back to our Data Explorer and to see what happened. Hit refresh and see our new database and new container provisioned. And within that container, you can see there's item that we created during the demo. Of course, if you'd run this code multiple times, it would create multiple items because ID is generated dynamically. So let's go into last demo. Let's do into querying demo. So in my to-do database, I'm gonna create new container called families. And I'm gonna hit maybe what kind of partition key we would want to design. Since my data will always have creation date as part of the data, I'm gonna pick that as a partition key. I'm gonna hit OK. And in my families, I'm gonna create 2 items with some additional information. So first one is Wakefield family item. I'm gonna hit save. And the second item that we're gonna create is Anderson family. I'm gonna hit save. And right now we have 2 families. As you see, those documents are a bit more complex than the usual. So you have parents, you have some children information, each children have some information, the children have some pets, their addresses. So you see a bit more complex structure than normally. And this is what is actually great about the Cosmos DB. So right now let's try some queries. So let's open new SQL query window. And first of all, select with where clause. So select a specific family. So this family actually works, right? So we selected family where ID was Wakefield family. Query stats, that was actually 3 request units, so quite expensive just for simple select. And this is because the ID is not our partition, so our query is not that efficient. The second one that you see, we can actually maybe join some information about the children. So let's run this query. This cost us 3 request units, and the result is the name of the children in the Wakefield family. Next query that we're gonna run is a query where we actually create objects. So this is a more powerful than the usual query because you can actually create objects. So you can create new object with a name and a city and join the information from your data. So let's execute it. And this is how it looks. A family, Wakefield family, is in the state of New York. Let's go to query stats. This is again 3 request units. Let's go to the next query. You can also, besides objects, you can do arrays. So you can list some information like city states. Let's execute this query. This returns a city and a states that the city is in, right? There's Seattle in Washington, New York in New York. So what else you can do is you can do aggregates. So you can paste this query to count how many children there are in all the families. So let's execute this query. There are 3 in all the families. And again, 3 request units because it had to go through all the data that we have. SQL in Cosmos DB is quite powerful. You can do a lot of stuff in here. Although this database is not super designed to be performant against query aggregates, it recently got updated, so the performance of the aggregates is much better than previously. So this is currently being rolled out, so it might not be there for your database yet, but if you need to, just write to Microsoft and they will enable it. If you're watching this video probably a month from the release, it's probably already there, so you don't have to do anything. But the query performance for aggregates got severely improved in the recent months. So that's it for the SQL API. So let's just lastly go through some of the options in the portal. First of all, you have replicate data panel. This is a great panel because you just select with a click of a button that you maybe want East US 2 and maybe you want some Southeast Asia regions, and you hit save and your data will be automatically configured to be automatically replicated in those regions with no downtime. You're actually gonna get that list here. So you have you have write region North Europe, but you also have read regions East US and Southeast Asia. While it's updating, I'm gonna go to the next tab, because next tab is the one that we'll care about the most. So this is the consistency tab. I did briefly talk about this when I was talking about the Cosmos DB in the beginning. So let's go through the consistency. By default, you have enabled consistency called session. So within your session, even across regions, even in North Europe, East US, whenever you're reading data and writing data, it will always come at the same time. But for other regions in other sessions, data will eventually come. It might come at different time, but what will remain is the order. So if the red comes first, the red will go next. Next blue, blue, purple, purple. A bit less consistent, less loose consistency level is consistent prefix. Consistent prefix says that even within session, you don't care about this. The only thing you care about is the order. So if you wrote ABC into database, you want ABC in that order. So always red, always blue, always purple. But across regions, it will eventually come there. And last, from the loose perspective, is the eventual is the fastest consistency level, but is the, let's say, designed to be the quickest, but it also loses some of the consistency, right? So first of all, it loses the most important one for many applications, which is the order. So if the first came red, it might come first, but it might not. So you need to remember that the data will eventually get there, but it will get there in any order, any fashion that will be suited to Azure itself. And if you go on the other side of this consistency slider to the bounded staleness, you will see the lag and the latency. So here you can configure two things: that you want your data to be delivered into other regions within either 100 milliseconds, 100 operations. So if you do 101 updates, you already tell to Azure that you want your data to be available in another region. Or you specify that the maximum delay that you expect your data to be in another region is 5 seconds. And the next one, strong consistency. This is the slowest, while still very fast, but slowest consistency level, where you simply say that in all regions, both reads and writes, you expect that your data will land there at the same time. So as you can imagine, because this needs to be replicated in real time, there's gonna be some delay. And go to the next, you have a firewall. Firewall is basically an integration that allows you to secure your Cosmos DB. If you have some important data, I advise you to go here. Course, again, a HTTP request header. If you're working with JavaScript single page application, you can use this to connect directly from JavaScript. There's even JavaScript API to work with Cosmos DB. There are key section. Of course, you can work with your database here. What I like to do after demos, just hit regenerate key, so that, of course, no one will be able to reuse that. Of course, I cannot do it right now because I'm rescaling database, but I will do it later on. You can just hit this button and regenerate the key to get a new one. One of the two cool features that we're talking about right now is Add Search. Azure Search allows you to synchronize your search service with what is contents of your Cosmos DB and allow you to query data through the search. So if you're, let's say, keeping some information about the people that is searchable, you can use Azure Search to even extend the performance of the Cosmos DB. And lastly, you have Azure Function. So this integration is one of the coolest features that I was even talking about, the change feed. So you can quickly just click few buttons here, And whenever there's going to be a change in your Cosmos DB, an Azure function will be executed that will pick the changes from the Cosmos DB and allow you to work on them in real time. And some additional features are, even if you go here, they direct you back to the portal and to the Data Explorer. So I'm not gonna talk about those. And others are standard ones like browsing of the containers, scaling. One of the cool features about browsing here is the estimated cost. So notice that you're gonna get that estimate. Right now we created a couple of databases and containers. So my estimated cost is 64 hundreds of thousands of dollar per hour. Of course, this will grow significantly when my scaling finishes, but always check this later on. Remember, you also have that in the overview tab here. So if you need that. And I guess that's it. And that's it. I hope you like Cosmos DB and you will find use cases for these databases in your projects. All the scripts and the data are available in the section down below. If you like the video, hit thumbs up, leave a comment, and if you want to see more videos, subscribe and see you next time.